Hey everybody, thanks for watching another math video here. This one is going to be about right triangle trigonometry and a kind of a funny sounding word, SOHCAHTOA. In this video, what we're going to look at is the basic definitions, the basics of right triangle trigonometry, the trigonometric ratios and all of this. We're going to look at the definitions of those things. We're going to look at a helpful little memory trick for writing the equations that you'll need to be using. And we will get a chance to do a couple of examples where we find the missing side length of a right triangle. All right, so let's take a look at these definitions here. Defining these trig ratios here. First off, I want to make sure no one's too troubled by the word ratio there. A ratio is just one number divided by another number. And in this case, the numbers come from the side lengths of the right triangle. So it's just one side length divided by another side length. That's all a trig ratio is. So in our right triangle here, the hypotenuse, all right, that is right there. That's the hypotenuse of the right triangle. It's always the longest side of the right triangle across from the right angle. And you see the angle theta there in the lower left part of the right triangle. Well, the side across from that is called the opposite side, all right? That's called the opposite side of the right triangle relative to that angle there. All right, and the other side of the triangle is called the adjacent side because it's next to the angle. Now, it's important to understand that while the hypotenuse never changes, the sides labeled opposite and adjacent could change if we're talking about, let's say, the other angle in the right triangle, the one up there on the top of the triangle. If that's the angle that we're using, then those words opposite and adjacent would switch places. All right, so that's kind of an important detail. The first ratio that we're going to look at is opposite divided by hypotenuse, and that is called the sine ratio. So you read that as sine of theta equals opposite over hypotenuse. Sine of theta. All right, that's how you read that equation. The next ratio is adjacent over hypotenuse, and that is the cosine ratio. So cosine of theta equals adjacent over hypotenuse. The last ratio that we're going to look at in this video is opposite divided by adjacent, and that is the tangent ratio. So we have three trig ratios, sine, cosine, tangent. We're using three different sides of the right triangle, opposite, adjacent, and hypotenuse. And each trig ratio is a specific pair of those sides. And it does get a little confusing at first, which is why people have been using this funny sounding word, SOHCAHTOA, to help remember this. All right, SOHCAHTOA is just really what it is. It's called a mnemonic device. It's a little memory trick that helps us remember the structure of the equations. All right, so let's take a look at this in a little bit more detail here. So in SOHCAHTOA comes from the sine ratio. Sine is opposite over hypotenuse, so SOH. There you go. That's so for SOHCAHTOA. The middle part of SOHCAHTOA is from the cosine ratio, adjacent over hypotenuse. So there's CAH, cosine, adjacent over hypotenuse. And the last one is the tangent. So we have sine, cosine, tangent, SOHCAHTOA. That's how it works. All right, so it's just important for you to remember this funny sounding word is just a mnemonic device, a little memory trick to help you remember what the equations, how the equations are set up. All right, let's take a look at a little bit more specific example with a right triangle here. Let's put some points there. There's angle theta. Okay, so there's the angle that we're talking about. Let's put some numbers there, 3, 4, and 5. That makes a good right triangle. So look at the right triangle there, angle theta. Think about for a second which side is adjacent, which side is opposite, which side is hypotenuse. All right, so let's write the sine of angle theta. Well, it's 4 over 5. Sine is opposite over hypotenuse. And you can see there across the right triangle from the angle theta is 4. That's the opposite side. So 4 over 5 is the sine of theta. That's all it is, just 4 over 5. The next one, the cosine of theta, that's the adjacent side right there. There's the adjacent side. That's 3 over 5. So the cosine is 3 over 5. Sine is 4 over 5. Cosine is 3 over 5. Opposite over adjacent opposite over hypotenuse or adjacent over hypotenuse. What I said right there accidentally was the tangent ratio, right? The tangent ratio is opposite over adjacent. That's 4/3. All right, so there's the three trig equations for that angle of that particular right triangle. And what I'd like to do before we do a specific example is emphasize this very important point. I've written the three equations there like that, and I really want to emphasize the point that you must get in the habit, every time you do one of these problems, starting every problem by writing the trig ratio equation for your triangle. All right? I cannot emphasize how important it is as a beginner that you start every problem the same way, writing the appropriate trig ratio. Well, that brings up a question though. How do you know which trig ratio to use? That will be probably one of your biggest challenges at first, is deciding which trig ratio to use. Well, that's what SOHCAHTOA is for. So what I want you to do when you start these problems is ask yourself these two very important questions. All right? First question is, what do you know about the triangle? What side is already given to you? The second question is, what do you need to know? So what do you know and what do you need to know? When you answer those questions in terms of opposite, adjacent, and hypotenuse, the sides of the right triangle, that will tell you which equation that you're going to be using. All right? Let's do a couple of examples here. So this triangle has a 72-degree angle. One side is labeled 50 and the other side is labeled X. All right? So think for a minute which side is labeled X, opposite, adjacent, or hypotenuse. Which side is labeled 50, same kind of thing. So answering the question, what do you know? Which side do you know? Do you know the opposite, adjacent, or hypotenuse? That's right, you know the hypotenuse. All right? What do you want to know? What do we need to know? And that is the opposite side of the right triangle there. Up there, that is that long side that's opposite across the triangle from the 72-degree angle. All right? So when you think about SOHCAHTOA, the O and the H for the opposite and hypotenuse come from the SO part of the equation. So we are going to be writing a sine equation for this right triangle. Here's what it looks like. Sine of 72 degrees equals x over 50. That's the equation, and that is a pretty easy equation to solve, right? Solving for x here means you're just going to multiply both sides by the denominator by 50. Multiplying on your calculator, 50 times sine of 72 is more or less 47.55. And that's how long that side x is there on that right triangle. All right? Comes from writing that simple trig equation for that particular angle. Let's do another one real quick here. Here, this triangle has a 40-degree angle, and one side is labeled 7.5. So I'll pause just a second while you determine for yourself which side is the 7.5, adjacent, opposite, or hypotenuse. Same for the x. So what side do you know? You know the adjacent side. What side do you need to know? You need to know the hypotenuse. So when you think about SOHCAHTOA and adjacent and hypotenuse, well, that shows up right there in the CA part, the cosine ratio. So your equation then, cosine of 40 degrees is adjacent over hypotenuse, 7.5 over x. So our x now is on the bottom of the fraction. So we can do this little flip that we've been practicing in class. And it makes it pretty simple. The x then switches places with the cosine 40. And all you're going to do on your calculator is 7.5 divided by the cosine of 40. That's approximately 9.79 inches. And that's how long that hypotenuse is. All right, and it does make sense that the hypotenuse is a bit longer than the adjacent side there. All right, so the hypotenuse is always the longest side. So that kind of makes sense in that problem there. All righty, well, that's a couple of examples. I hope that was helpful for you. Feel free, of course, to go back and look at those definitions again. I may have gone by them a little bit fast, but you can scroll back and look at the video as much as you like. And don't forget to always start these problems by writing the proper trig ratio equation. All right, it's a very important habit to get into. Also, don't forget how to spell SOHCAHTOA. All right, that's kind of important too. Hey, once again, thanks for watching. I hope you're doing well in all parts of your life. And now let's go do some math.